Alright, so this is part 2 of my earlier video. So this is my controlling mechanism for everything. Basically, it's a Raspberry Pi, which is a mini computer. So it's a Raspberry Pi with an adapter shield on top of it called a Pi a la mode, believe it or not. So the white one in the middle is the Pi a la mode. This little piece of cardboard right here is just to keep things from contacting, the a la mode and the Pi from contacting and shorting out. And then on top of the Pi, on top of the Pi a la mode, which acts as an Arduino interface, I've got an Arduino CNC shield. So this is a CNC shield with 4 stepper motor drivers. So each one of these drivers is a stepper motor driver. It can drive, each one of these can drive one stepper motor. And the stepper motors are using pulse width modulation to turn. So what I've done is I fashioned a wiring harness. Basically, these 4 pins for each one of these stepper motors are what you got to send the signal to the motors with. So I've got a little 4-pin connector, and then I built a little wiring harness where I took those wires and I put them into a CAT5 female connection. So I've got the right wiring configuration. So basically the idea is that this whole thing will be in a box, and that box will have, RJ45 connectors on top of it. So this guy is going to go here. I'll put this in one of my Ys. This is actually the Y-axis. This is the Z-axis, and this is the X-axis. This is called the A axis on this particular shield, and it allows you to clone one of the other 3, or you could actually use it for like a 4-axis CNC machine where you're building things with your router at an angle. So at any rate, there's that. So this guy is my RJ45 connector. So over here on the other side of my office, I've got my stepper motor, and you'll notice that the stepper motor has 4 wires as well. So the stepper motor, again, I've wired into an RJ45 female, again using the right configuration. You have to figure out which of these are pairs and what the polarity is for the right polarity, so that when you're clicking on your software system, for instance, this is my up and down for my Z-axis. You want the up to go clockwise and the down to go counterclockwise. If your polarity is backwards, then those will be backwards. So here's the deal. So what's really cool is now I will take this, plug in my RJ45 cable. So the idea is that the motor can be pretty far away from the other unit. So I've got my RJ45 cable. Sorry for the terrible video. I'll pop that guy in. Alright, so now I've got my my Y-axis controller connected via a standard RJ45 cable that just came from like Lowe's or anywhere. And when I jog my Y-axis, moving. Pretty cool. The only other thing that I would recommend, if you're looking at implementing this, is I made a little spreadsheet that mapped out where my wires were going. So first I figured out using a breadboard where how all my connections needed to be, and then I made a little mapping table to show with this specific motor and this specific wiring harness and this specific CNC stepper driver setup exactly how the wires are supposed to map to the RJ45 connector so that everything lines up. So enjoy.